Energy System Modeling Exercise 8. So let's go ahead and open the exercise 8 folder. So I'm going to download these. And from here, let's open the PDF and the template. So this time, what we're trying to do is we're trying to understand the effect of grid scale battery and consumption flexibility on electricity price. And let's go ahead and see the assignment. So use the exercise 8 template file and formulate the merit order curve for the examined system based on the asset capacity and electricity production price. So let's go ahead and do that. So in here we have, similarly as in the previous exercises when we were examining the electricity system, we have the production assets, we have the prices in here, and we have the capacities in here. And in here, I have in the template already derived the cumulative capacity of those assets. So these are just arbitrary numbers, but they kind of represent the price range that we could be experiencing in our own production. This might be a bit low estimate on the most expensive production systems in Finland, but however, we're in the same magnitude. The capacity, though, is a bit, let's say, half of what we should have. But as I said, this is an arbitrary example, so let's go ahead and use these in the examinations. So for the merit order curve, what we need is, let's go ahead and draw it. So I'm going to put whiteboard on. It's always good to draw or sketch what you are after to some extent, so it's easier to start working on it. So what we need is we need the cumulative capacity in here, and what we need in here is the price. And the merit order curve means that you have a certain capacity of an asset with a production price of, for example, this was 0.1, so that was the lowest, and the next one was 1 or 10, and so forth. So this is going to rise up. Let's close that gap in there. So we're going to need the cumulative capacity and the prices in here. So for Excel, you're going to need this point and this point. And when you're drawing this line upwards, you're going to need this point and this point. And this way of doing it, it's a bit rigid, but and you have to do some manual work in here. So let's put the capacity in here. So it starts from 0, and the next number is going to be this one. And the next point in here, you need 500, and then you need 500 again. So we're going to do it like that. So as I said, this is going to be a bit of a manual labor. I didn't quite figure out any other way of doing this easy. So we're just going to say that always the next capacity number, and the next is going to be the previous value. And I'm going to put cell references in here in order for us to change the capacity. And the final one, I guess, is being this one. And actually, since we need the price in the same way, what I can do now is I can go ahead and switch the prices in here and drag like this. But now I need to move these, I'm guessing, upwards just a bit. It starts from this 0.1. So I'm going to move these upwards a bit. And again, in here, say 100. And let's move this backwards. And let's see if we, so this is the price and capacity. Capacity, it's good to write those all together so it's easier to decipher later on what's been going on. So let's go ahead and insert a graph rather this way. Yeah, so now we have the merit order curve in here. So I can go ahead, actually, let's put the axes in there. So from chart design, you can use this quick layout to get the axes. Remember, you always, if you're going to attach these to some scientific writing, you're always going to have figure captions, so you don't need any titles in here. And let's lose the border. Yeah, so this is price in euros per megawatt hours, and this is going to be cumulative kappa in megawatts. So now we have the merit order curve, and then in these kinds of let's say quick and dirty simulations, when you are trying to kind of capture the phenomena and examine it, but you don't want to make too complicated calculations or models. So to make it, as I said, quick and dirty, it's beneficial if you're able to use to produce, for example, a consumption curve. It's beneficial if you're able to use different function combinations to make, for example, this sine wave and adjust it in a way that it's suitable for our system. Because you want to be able to modulate somehow easily the system consumption in this case, for example, so that we can see the effect of that on the system. So what we can do is we can use, for example, a sin function, and I'm gonna copy it from from my other file. So you can see what I have in here is I have the maximum capacity in here. I'm going to multiply it with 0.9. That's an arbitrary decision, and you can change that later on. And then I have in here the amplitude for this consumption wave. So this is again pretty much an arbitrary decision. So you can do it other ways as well. But so this is the baseline consumption, and this is the sin wave for it. So amplitude times sin, and in the columns, or you're going to have this time. So this is not actually time, this is the number of the hour. And I decided to have it divided with 3. So what it's going to make for us, it's going to make a nice change in the consumption. So that's going to be a sin wave. And if we want to modify it, we can decrease the amplitude, for example, if we feel that it's a bit too drastic of a change. But let's leave it like that. So now we have some sort of a consumption in here. And what we want next is we want to use this because these are in price order, the assets in here. So we want to find the price that is resembling this consumption. And actually, I can put, if we're talking about an inelastic demand in here, we can say for the demand, there is X values and there's Y values. And in this case, if we have an inelastic demand, so all of the consumption is willing to pay the same price, then we can say that this is going to be the consumption. So X in here is going to be consumption, and the next one as well. And the price in here, so the Y value is going to be 0. And then let's put it to be the maximum of this system price. So now if I add this in here, not even going to label it. So X values in here and Y values in here. You're going to see, I'm going to change the color for it to be a bit more bright. Yeah. So now you can see the inelastic demand uh, bidding curve. So all of the customers are paying just one price for the consumption, and that is where the crossing of these functions is that determines the system price. So in here, what we can do is we can use match function. So we can find this one from here. So let's go ahead and use match function in the beginning. It asks the lookup value and then lookup array. And I'm going to dollar that. So you can see it's number 6. So in here, we can see 1, 2, 3, 4, 5, 6, and it's going to be the next one. So we can use this. So we found which asset is going to be fully activated, and the next one is going to determine the price. So now we can use this index function, and based on this match, we can find the price. So let's go ahead and I'm going to control X this one, and I'm going to use it in this index. So index asks the array. The array can be a vector or it can be a matrix. So now we just have a vector that's going to be dollared. It's going to ask the row number, and that is going to be the match plus 1, as we determined before. And column number is going to be 1. So it returns us the price 30, and in this case, it seems to be the case. I'm going to add the tick marks in here, so it's going to be a bit easier to see from here. Yeah. So it's right in the middle in here, it's 30. And let's go ahead and determine the price for the whole system. And now I can see that it looks something like this. So this is the hour number, and this is the system price. Then the assignment, actually, we went, yeah, well, based on the asset capacity and electricity production price. Yeah. So the second part, determine the price of the electricity-based consumption. This was done. And then determine the effect of grid scale battery on the electricity price. So grid scale battery would mean that we have, for example, a battery size of, well, these are arbitrary numbers again, battery size of 6 gigawatt hours. So that's a huge battery. And the charge rate would be 500 megawatts. So this is just for an example. These kinds of batteries, I'm not sure, at least not in Finland. I think it's somewhere close to 200 megawatts that's in the Baltic countries, but the battery size isn't that high. But in the future, these are coming. So let's put the initial charge in here. So state of charge initial. And this is going to make this model a dynamic model in a sense that you have to refer to the previous time step in these calculations. So these are not just isolated single or isolated slices of time that you can calculate based on what's happening just within that time step. You have to take into account the history. And now, actually, the state of charge is going to go in here, and the charge. We can determine, as before, different strategies for charging and discharging the battery. And in this case, we're going to select the kind of simplest one of those, which is the price threshold. So that states that if we have a price below 25 euros per megawatt hour, we're going to charge the battery, and then if not, we're going to discharge it. So let's make it in a way that we have an if statement in here. So if the price is going to be above 25, and this is going to remain constant, then it's going to be, so if it's above, then it's going to be minus. So we're going to discharge, and otherwise we're going to charge. Let's see that if that seems reasonable. Something's moving in here, so this one, like that. So it's either charging or discharging. And the state of charge, now that you have, this is kind of like the strategy. What are you going to do with the charging and discharging rate? So then we're going to calculate the state of charge. And in here, we're going to take into consideration that the state of charge cannot go below zero, or it cannot rise above this rather 6,000 megawatt hours. So let's say that if this one plus this one goes below zero, then give me zero. Otherwise, we're going to have another if statement in here. If this one plus this one goes above 6,000 megawatt hours, then give me 6,000 megawatt hours. Otherwise, you're going to give me this one plus this one. So let's see if that works. It doesn't go below zero. And even if we were to increase this charge rate, let's see, it doesn't go above 6,000. So that seems to be somewhat reasonable. So then our consumption is going to be, if we're going to use this grid scale battery in the spot market, the consumption in here, we're going to discharge it. So we're going to sell part of the electric energy from the battery. So the overall consumption curve is going to move downwards. So the battery is going to start decreasing the prices. So consumption plus the charge. So the consumption is going to decrease. Well, the consumption is going to remain the same, but the battery is going to sell a part of its profit in here. So that's going to have an effect on the price. So this means that the battery operator must have made a bid to the market that is below this 30 euro per megawatt hour. So now we can see the price again. So I'm going to just copy paste this one into here, and we're going to change from this consumption into here. So you can see that if we take into consideration that the consumption curve is going to move, so I'm going to take this one in here. So you'll see it changed to this 25. And now what we have is the other price curve. So if I'm going to plot these together, so I'm going to use this line plot like this, and not the cumulative, but rather the one where they cross each other. So this is going to have the original system price and the price with battery. So you can see that it cuts the peaks and fills in the valleys. So it's going to make the deviation in the electric price smaller. So there we have the first part, so determining the effect of the grid scale battery on the electricity price. And then we want to determine the effect of load flexibility on the electricity price. And the load flexibility means that rather than having this kind of an inelastic demand, we can have load flexibility. So this inelastic demand can drop down to the same level, or rather the previous level of the electricity price. And we're going to make it in a way that in here was the 100 euros per megawatt hour. So in here, we're going to state that we have a load flexibility of 500 megawatts. So what we need is the slope of this curve. So we're going to say y equals slope times x plus b. So we can determine this slope at first, because that's going to be delta, let's see, delta y times, or rather divided with delta x. So delta y is going to be the price change in price, and this is going to be the change in capacity. So let's see what we can get out of that. So we have a 500 megawatt capacity change, and this is going to be 100 euros per megawatt hour. So let's go to the template second part. And in here, actually, we can use the same consumption pattern in here. So let's put it in here, and I'm going to switch it into here. Actually, there's 1,500 in there. So like this, now we have the consumption function, and let's take the price out of here as well. So I'm going to put it in here. So yeah, seems to be on the same spot. So it finds the price immediately. So then what we need, we have the slope or the straight line equation in here. And what we want to determine is the slope of the curve. Because what we are after in here is we want to know if this consumption, if it was here, if this load flexibility 500 megawatts on this upper price range, if it's going to change it in a way that it's going to drop down to the next or the previous level, or maybe even 2 levels down. So for that, we need to find the intersecting point in here. And this was rather hard to do in Excel since we have this kind of a piecewise function. So there are these discrete step changes in here. So, and it's not a continuous function. So we're going to have to use some mathematical shenanigans in here. And I'm not sure if this is the best way to do it, but this is one way to do it. It's a bit clumsy, but bear with me. So let's first calculate the K value, and that's going to remain the same. So if we have the maximum price, so delta price is going to be this one all the time, and we're going to divide it with 500. And again, this is an arbitrary example to kind of make you learn how the system behaves. This isn't actually how this bidding curve for the demand side would be formed. So that's also this kind of a stepwise function. But for the sake of simplicity, we're going to make it a straight line, and this is going to be, let's have minus in there since the flexibility is going to be negative, or the change in the consumption. And then what we need is the B. So for this B, let's go to the drawing. It's easier to see from here. The B can be calculated when Y is 0, and if we know K, and if we know X, because this line can be based on the consumption amount. So this is kind of the, if price were 0, the consumption was this amount, and then we always have the same slope in here. Then based on the consumption amount in here, we can calculate from this equation. So Y is 0, we're going to move B to the other side and divide with X. So this is going to be minus B divided with X, which is the consumption. And that doesn't seem right. Did I do it the wrong way around? Oh, we're after B, so it's just K times X rather than divided. So K times X. Yeah, that seems better. Okay, and I can actually go from here if we have these in the same places. So J3 let's see if I put it into here, J3, you're going to have to be specific with the place. So now we have the same references in here. So it refers to the right place in these numbers. So we can have the same kind of curve into here. I'm not going to bother to modify it too much now. And after that, we can draw, for example, this curve in here. So let's put the demand function in here. So demand X and Y. And for X, the first thing we have this one. And the next one is going to be this one minus flexibility. So first is 3,000, or rather close to 4,000, and the final value is going to be somewhere in between here. So this is going to be 0, and this is going to be 100. So let's go ahead and draw it so you'll see how it looks like in here. So X values in here and Y values in here. So now we have the elastic demand function in here. And if we were to change the consumption value in here, so if we were to put 2,000 here, the price curve for the demand is going to move accordingly. And we still have the same slope. That wouldn't be the case, but for the sake of simplicity, we're going to use that assumption in here. So now the problem lies in where to find the intersecting point. And as I said, since this is not a continuous function, but rather this kind of a piecewise function, step function, we have to do some mathematical shenanigans. So let's go ahead and draw this again. If we have the consumption bidding line in there, and then we have the price levels. So this was, for example, 0.1, the next one was 1, and maybe this was 10. We can calculate the intersection of those points in there, and then calculate the X value. And then we can see from the curve in here, so if this, let's do it in this way, so like that, and this would be the next price. We can see whether this falls in between the range that's given in the cumulative capacity. So for example, this point doesn't fall into this range. So we're after all of these ones. So let's put a transpose of those prices. So that is going to be kind of our tag. And what we are after is just the intersection point. So let's see from this drawing what we are after. We are after this point. So this one, so y equals kx plus b. We know this one, we know this one, and now we are after this x, and we know the price. So y is the price. So in this case, if y is going to be the price and we're after x, so it's going to be y minus b divided with k. So in this case, y, that is the price, minus b, that's in here, divided with k. And now this price can move sideways. So I'm going to put dollars in the number only like that. B can move downwards, so it has to have dollar in there, and this can move only downwards as well. Let's see if it works like this. So if I drag it in here, these are going to remain constant, and the price is going to change. Okay. So now that we have all of these calculated, so these are the intersecting points. And what we need after that is to see whether this falls into the capacity range in here. So I'm just going to say that actually it might be beneficial to put the transpose of these ones in here. So we're going to see whether this value in here falls below this one. So let's see if this value in here is below this one. This has to stay constant from the row number, but not from the column. Then give me 1, otherwise give me 0. So let's see if we get it. Yeah. So at 4,000, in this case, it's gonna activate it. So let's try if we change the consumption. If we have consumption over, let's say, 4,200 and add flexibility of 1,000. Yeah, so it changes this one. And if we don't have any flexibility, then it's going to be this 1, 2, 3, 4, 5, 6, 7, 8 asset. So let's return this one back there. So now based on that, you can determine the price. So we can use the same index function as before. So what we're trying to find is we're trying to find based on this number. So 1, 2, 3, 4, 5, 6, and 7th asset. So 1, 2, 3, 4, 5, 6, and 7th asset is going to be activated. So let's have an index. It asks the array we're determining the price that is going to be activated, and it has a total number of 10. So we have 10 minus sum of all of these ones, and then we're going to have to add 1 because it's the next one. And then column number is going to be 1. Let's see, that's 30. And if it works, it seems to work. So let's draw these two curves now on the same graph. That doesn't seem right. So this one, yeah. And now you can see again that our peaks are being cut, but nothing is done to the valleys. So our consumption, by the way, let's see how we can calculate that one. So it's going to be based on the price. So let's go back to this drawing. It's easier to see it from here. So what we're after is if we have the initial consumption in there, what is going to be the consumption in here? And since we know the price, we have the K and we have the B, then we can calculate X. So X is going to be Y minus B divided with K. So let's try that. X is going to be Y, which is the price, minus B divided with K. Let's see if it gives a reasonable solution. Yeah, seems to be. So now we can also plot. So this is the price, and this is going to be the consumption. So consumption in there and consumption in there. So now you can see that the consumption is only being decreased, and that is reasonable with this consumption flexibility. So, or the load flexibility. So if there is this much capacity to make this flexibility and it's being activated, it means that the system is only gonna decrease the consumption. In this battery case, it was in a way that the system could increase the consumption during this low level of consumption, or the low level of demand, rather, where there was a smaller price. So you can cut the peaks and fill in the valleys. In here, you're only decreasing the consumption because it's too expensive. So there was a way of drawing the merit order curve, drawing this flexibility or flexible demand. And then what we were after the asset that's being still activated in here. And the final question in here is determine the combined effect of the two phenomena on the price. So let's go ahead in here and have the consumption and price function. From here, we might have to change something. So this is going to be the maximum, and the amplitude was in here. So let's see if we can get the consumption going on, and then the charge, or rather, that would be the price. So let's calculate the price in here. So I'm going to move this one in here. So price without the battery. Let's check the battery first. So finding the price, and then we have the charge. Let's take the charge function from here. I'm going to put it in here, and it's the price. Actually, this one should be in here. And this is the price threshold, and this is the charge rate, like this. And then we can go ahead and copy these state of charge values from here. Going to change this one to 5,000 megawatt hours. And in here, the limit is again the 5,000. So we get the state of charge again, and the consumption function in here. Let's be lazy and copy it from here. So consumption and charge. By the way, I seem to have made a mistake in here. So if we calculate it this way, it's wrong. So that's a good thing that we can correct this. So never use this charge in this way. You want to see the state of charge rather, because you can see in here there is discharge, but nothing is, so based on our strategy, there should be discharge, but nothing is happening since we don't have the capacity for it in the battery. So let's make it in this way. State of charge minus this one. So that should be correct, and it might actually change this a bit. I'm not sure if it does. Might have in some cases, at least in these ones. But yeah, that's corrected. So let's use that one in here. It was good that we didn't code up that one. Okay, so now there's the consumption, and we can see the price with the battery. So let's use this price without the battery and price with the battery. So that is going to be our consumption. And now what we are after is the consumption flexibility. So let's take these ones from here, put it to here. So the transpose is going to be the price, and this is going to be the cumulative capacity tags. And we have to calculate the P and K. Let's see if we have enough room in there. Seems not. I'm going to put one more in here. So that's K and that's P. So calculating these ones, going to copy these ones again in here. So let's see, how did we do it in here? Already forgot. So that was so the flexibility maximum and the price. So flexibility maximum, this was price, and flexibility maximum was 500. And now B is being calculated correctly. So we can do like this. And from this consumption flexibility, I'm going to take this one and copy it to here. So not state of charge, we can see from here. So it was price, and then there was K and B. So price, K, and B. So till 100 and to the end like that. So those are the intersecting points. And then we still need the consumption flexibility values, or rather the values that are of the assets that are being activated. So we're after this one and the consumption. So modifying from here, we're going to have this 500 is going to be the limit. And this one is going to be the examined point. So again, we're after at which point is it going to cross. So maybe I'm also going to have these ones for us to see it better. So I better change the location of these ones. So it's going to be a bit easier to match those ones. So this starts from C4 in here, C3 rather. So let's move one up, and J3. Yeah, seems to be correct. So now we get the I'm missing something from there. Yeah, missed one of these values from here. So there, now we have the merit order curve. And then we can have the consumption flexibility. So let's take the demand in here. So demand at X is going to be this one. And then this one minus 500. So that is going to be our flexibility, or this demand price with this flexibility. And what else? So we're after these ones. So in the first case, we'll see if it actually is the case. So 3,100 is being activated still. Oh, yeah, by the way, we have to, in here, we're gonna have to use this one. So now we have the battery effect in it. So the battery effect is going to be there. So now it looks better. There's 3,100. So this is going to be activated. It seems to be still seeing here in this one. Yeah, seems to be correct. So these ones, and then we'll just need the price and the final capacity. So the price in here, yes, and capacity, yes. So let's now draw three curves. We'll have the consumption of all of these different cases. So we'll see how they behave. So this is the original consumption. I think, yes, this is going to be, the orange is going to be the one where the peaks and valleys are going to be, or rather the peaks are going to be shaved and the valleys are going to be filled. So this is where the battery comes into play. And this is what the effect of this load flexibility is. So if I were to copy this chart and I'm going to move these ones to the prices, so price without the battery, price with the battery, and price with consumption flexibility. So you can see that the battery in here cuts the peaks, fills in the valleys, and then the load flexibility in certain points, it cuts the consumption like this. So there and here, and also in the beginning. Yeah. And now when you have this quick and dirty kind of simulation done, then you can start playing around with, if we increase the flexibility, how is it going to affect to the system prices? If we increase the charging rate, for example, into here, it starts to look much more leveled in the electricity price and also in the consumption as well. So those were the points to cover in this exercise.